So the Mersenne twister has, as we said, 624 internal states. And they're calculated like this. They all depend on previous states. So calculate this H value, and this here, Y at the index I minus n, I minus 624, minus Y, the same Y, mod 2 to the power 31, well, one number minus the same number mod 2 to the 31 is just a mathematical way of saying we take the highest bit of this state. So our state depends on the highest bit of the state 624 states earlier, and on the lowest 31 bits of one state afterwards. And then the actual state is calculated by taking the state's index minus 227, so 227 states ago, that is XORed with this H value. This divided by 2 and then rounded downwards is just a mathematical way of saying we right shift by 1 bit. So we lose the last bit. And then we XOR it with H mod 2, so the last bit of H times this constant. So that's just a mathematical way of saying that if the last bit of H is set, if the last bit is 1, then we XOR this here with this constant as well. And as I've said, all internal states are 32 bits wide. So first thing we can see is an internal state or an output depends only on 3 previous states. This one, and this one. So this is how a Python implementation could look like with an ever-growing state. That's just what we have seen in the formulas, just written as Python. But one difference to LCGs is that there's a difference between output and internal states. So we have seen how an internal state is calculated, but actually what's outputted is the internal state after post-processing. So post-processing is done as follows. We take the internal state, XOR it with itself, right shifted by 11 bits. Then we XOR this value with X left shifted by 7 bits and with logical and this, and then we XOR this value left shifted by 15 bits with the logic AND of this magic constant, and then we right shift this value by 18 bits and XOR it to itself. Now this looks pretty strange as an operation. This is what guarantees the equal distribution of the outputted numbers. And as it turns out, these steps are reversible. So if we get our hands on an output, this is the post-processing in Python, sorry. Just as we have seen it now. And this is reversible. So if we have an output, if we get our hands on an output, we can revert this step and then just calculate the internal state